The last thing we're going to talk about in Chapter 10 is uninhibited growth and decay. So many natural phenomena follow a law that an amount A varies with time t according to the function A of t is A naught, where A naught is the original amount at t equals 0, and of e to the kt, where k is our constant and t is our time. So if k is greater than 0, we have uninhibited growth, and if k is less than 0, we have uninhibited decay. So let's go through an example. A colony of bacteria grows according to the law of uninhibited growth modeled by the function n of t equals 100e to the 0.045 t, where n in grams, where n is in grams, t is measured in days. So what is the initial amount of bacteria? Well, the initial amount is going to be 100, but let me show you why. So if I have n of 0, that's 100 e to the 0.04 times t, which is 0. So n of 0 is 100 times e to the 0. Well, any number to the 0 power is 1. So n of 0 is 100. Our growth rate of our bacteria is our constant k, which is 0.045. So let's graph this function. I went ahead and graphed this in Desmos. As we can see, this is uninhibited growth. And at 0 days, we had 100 grams, and it continues to grow exponentially because it is an exponential function. What is the population after 5 days? Well, as t is measured in days, I've got n of 5 is 100 times e to the 0.045 times 5, which means n of 5 is 125. Note, I don't get a whole number, but we're looking at bacteria. And just like you can't have like half of a person or 2/3 of a dog, you can't have partial bacteria. So you need to round to a whole number. For question E, we want to know how long will it take the population to reach 140 grams. So let me bring up a whiteboard. So on 140 grams, I want to know what T is when I've got N of T, which is our amount, 140 grams. So I'm going to take, I originally had N of T is 100. Let's clear that and pick a better color. N of t is 100 e to the 0.04545 t. And I want to know when I have 140 grams. So I'm going to be solving for t, because remember, e isn't a variable, e is a number. So I'm going to take the natural log of both sides, because if I do that, then that's actually not the first step I want to do. What I first want to do is divide by 100. So I thought about taking the natural log of both sides to focus on getting this exponent out of our variable out of the exponent, but that's not what I want to do. First, I want to divide both sides by 100. And I'm going to do that so I can take the natural log of e, as the natural log of e is 1. So first, we divide both sides by 100. I get 1.4. I'll write it nicer, is e to the 0.045 t. Now, in order to get that t variable no longer to be an exponent, I take the natural log of both sides. So I have the natural log of 1.4 is, I can move this exponent to the front, 0.04 t times the natural log of e, which is just 1. So I have the natural log of 1.4 is 0.045 t, so I divide both sides by 0.045. So I get t equals 7.48 days, or we could just say 7 and a half days. So it takes 7.5 days for my population of bacteria to reach 140 grams.